All right, so we're supposed to use both methods described in example 3, which we'll kind of just show you here. So method 1 is use substitution in an indefinite integral to find the antiderivative as a function of x, and then evaluate the definite integral. And then method 2 is substitute directly into the definite integral, changing both of the variable of integration and the limits of integration. So we'll do two different ways and see if we get the same answer. So if we don't, we've done something wrong. All right, so first things first, we try to get a pen to work here. And we have for 1, we'll say it's method 1. We're going to say, okay, well, if we're using substitution, let u equal what? It's going to let it equal 2x plus 4. So du then is what? 2 dx. Okay, so that's not bad. All right, so 2x plus 4, that's going to be the denominator. Now to get 2 dx, that means we're going to have to multiply this by 2. So we have 2 times 1 times dx, so that'll be 2 dx. But whatever we do here, we have to make it so it's when you multiply that with that, we get 1. So we have to take 1/2 here. And so this then gives us 1/2 integral from 0 to 1 of 1 over u du. Okay, so that's all we've done. We've done this substitution. We've had to multiply by 2 here, 1/2 out here, and we have this. Well, now what do we have here? Well, that's going to be the ln. So that's going to be 1/2, and that's going to be ln, absolute value of u, and then plus our c, and then we're going to integrate from 0 to 1. Now, remember, when we're doing these, we're going to say, well, let's let c equal 0. Then we don't have to actually worry about that. And so when we do that now, if we go ahead and put all that back in, we're going to have 1/2 ln of 2x plus 4, and we're going to evaluate that from 0 to 1. Because now we added the c equals 0, we added u as 2x plus 4. Now we can do this. And so what's that give us? So it's going to give us 1/2, and it's going to be ln. If we plug in a 1 here, it's going to be 2 plus 4, that's 6, so ln of 6. And then we'll have minus 1/2 ln. Plug in a 0 plus 4 is 4, so that's ln of 4. And if we plug all that in our calculator again, for sake of time, I have the answer there. So that's 0.203. Okay. And so again, that's how you do it with just plain substitution. Okay. Now the next one, we're going to do substitution, and we're also going to change the limits of integration. All right, so with that one, what we have to do is we have to think about, for 2, we have to think about our upper and we have to think about our lower limits of integration. Well, here x is equal to 1, here x was equal to 0. And what are we doing? Well, we're going to use the same u equals 2x plus 4 and d equals 2 dx. So then if that's the case, if x is equal to 1, u is equal to what? Well, that's going to be 2 times 1 plus 4, so that's going to be what? 6. And here, u is going to be instead, it's going to be 2 times 0 plus 4, so that's going to be 4. So our new limits, instead of going from 0 to 1, like we have here or here, are going to go from 4 to 6. Okay. And so now the rest of the substitutions are all going to look the same here. So now we're going to say, okay, well, this is what it is. We're saying that our u's are now our new value variables instead of x's. And so now we're going to say, okay, well, now we're going to integrate, and that's going to be changed over to 1 over u du. And now we're going from 4 to 6. Okay. So when you do this, we get 1/2 ln, absolute value. But here, both of these are positive, so we can just say a u. Can't write a u, but anyway. And we're going from 4 to 6. So that's 1/2 ln of 6 minus 1/2 ln of 4. And if that's still the same, that's 0.203. So they both give us the same answer. So here, when we did it, we changed our integration limits here and here instead of 0 and 1. But when we get to the end, we don't go back unsubstitute. We don't go and say, okay, well, now let's go back in and say u is 2x plus 4 and du is, whatever. We say, okay, once we get to this, we've already changed it. These aren't x's anymore. These are u's. And so we just plug them in directly and we get that answer. Okay. All right, so let's stop there. We'll come back for another one.